This video will cover all the things you need to know about simultaneous equations for maths methods. So we'll start with these two variable problems, and you'll recall in year 11, year 10, probably even year 9, solving things like y equals 2x take 1 and 3x take away 2y equals 5. Method of substitution, method of elimination, solve, and what you do is you find the intersection point, or what usually is the intersection point. So you'll recall what we did in year 11 was introduce these linear equations, but we've got a parameter value, this value here, m. And as we vary m, one of three situations is going to arise. This one here is when we get a unique solution, and that occurs when m1, the gradient of the first equation, is not the same as the gradient of the second equation. The c value can be any real number. It doesn't really matter what the y-intercept is. As long as the two gradients are different, then we'll have a unique solution. Okay. All right. The second scenario is that we can get parallel lines. Okay. Now that's going to happen when m1 is the same as m2. Okay, so same gradient, and c1 can't equal c2. Okay, so they have a same gradient, different y-intercept. They'll be parallel lines. And the third equation is when the lines coincide, so they are in fact the same line. That's me trying to draw on top of the one underneath. And for that scenario, m1 equals m2, the gradients are the same, and c1 equals c2, so the y-intercepts are the same. All right, so the way I do these questions is that I carefully read the question. I go, okay, we want one unique solution. Then I find which of the three scenarios I'm after, and it's this one here. So m1 can't be the same as m2. So basically what I want to do is pair up the gradients and let them not equal to each other. All right, so the way I'm going to do that is I'm just going to go 2y equals negative mx plus 8. Y equals negative mx on 2 plus 4. So I've got it into y equals mx plus c form, so I can pick out the gradient and the y-intercept if required. This is part A we're answering here as well. All right, so the second equation is negative 2 take my equals negative 4x plus 2m. Y equals 4x over 2 take m. Take away 2m over 2 take m. Alrighty, so what we'll do is we'll pair up the gradients. So we've got negative m on 2 can't be the same as 4 over 2 take m. So I've gone ahead and grabbed the gradient here and the gradient here and let them not equal each other. Okay, so when we solve this, we've got negative m, 2 take m, can't equal 8 after we cross multiply. Now we've got m squared, take away 2m, take away 8, can't equal 0. M take 4, m plus 2, can't equal 0. M can't equal 4 and m can't equal negative 2. So they're the two values that ensure that those ones there, the two values says that basically it can't be these values here. So we could say something like m element of all real numbers, not including the negative 2 and the 4. Right, so choose any real number, but you just can't choose either 4 or negative 2. Now I'll let you think about why it can't be these two values here. I wonder what will happen if it is one of these two values here. Okay, and maybe you kind of can connect up that it's going to be either that or that scenario if it is one of those two values. All right, so let's do the second part, which is no solution. Okay, so B is no solution. So no solution occurs when m1 is the same as m2 and c1 is different to c2. Right, now we already know m1 equals m2 for m equals 4 and m equals negative 2. So we've worked that out. So to work out when c1 not the same as c2, we just equate the constant values from each of the equations. So we've got 4 over here, and we've got negative 2m over 2 take m. So 4 can't equal, what was it again? Negative 2m over 2 take m. 4 2 take m can't equal negative 2m. 8 take away 4m can't equal negative 2m. What are we going to get? Just going to continue it over here. Negative 2m can't equal negative 8. M can't equal 4. Okay, so the fact that m can't equal 4 for the constant value basically means that we're going to reject that one, which means, therefore, m equals negative 2. So that's when it's going to happen. All right, so I'm going to just explain graphically what this means. Okay, so in another window, I've just opened up, I've got GeoGebra, and what we're going to do is just type in the two equations in GeoGebra. So we've got mx plus 2y equals 8, and what it asks us for is the slider, and we've got 4x take away 2 take m, y equals 2m. All right, so as predicted, okay, we've got a unique solution when m equals 1, okay? Because really, for a unique solution, we just don't want it to be 4 or negative 2. Now, we worked out the answer to part B was negative 2. That's when the lines are parallel. So I'll just test that. So the parameter value m equals negative 2 means that the lines are parallel. Now, what about if we said it could be 4 as well? Well, no, because that's when the lines coincide. Let's see if I can hit it exactly. Oh, I can't hit it. Anyway, I think you'll get the point. There we go. Is that's when the lines coincide. So we're going to get infinitely many solutions for that particular scenario. Now, this question doesn't actually ask for that, so we're not worried about that at the moment. All right, so there is that one. Okay, now this one here, what I'll do for this one, I'll actually fire up my calculator. Okay, so what I'll do is go to calculator and menu, algebra, and solve system. And what I've got for the top one is 2x take 4y equals 6. And I think the bottom one was x take away 2y equals 3. And what we get is this rather unusual syntax. And what basically the calculator is trying to tell us is that there's infinitely many solutions. Now, what you hopefully can recognize here is if I multiply all of the terms in this equation by 2, I get 2x take away 4y equals 6, which is exactly the same as this equation here. All right, they're exactly the same equation, therefore they have infinitely many solutions. Now, what we're going to do is try and describe the infinitely many solutions with the use of a parameter. Now, the textbook uses this particular Greek letter lambda to be the parameter. You can really choose anything you want, okay? But just to stay consistent with the Cambridge text, I'm going to describe them through the use of lambda. All right, so I'm going to say let x equal lambda, where lambda is an element of all real numbers. Okay. So now what I'm going to do is I know my solution, my infinitely many solutions is lambda, comma, and whatever the y value is there. So I'm going to substitute lambda into this equation. Lambda, take away 2y equals 3. All right, now I need to find y. Negative 2y equals 3 take lambda. Y equals lambda take 3 over 2. And there's our infinitely many solutions. So I'll give you one possible solution. So it's when lambda is equal to 3. So 3 comma 3 take away 3 is 0. 0 divided by 2 is 0. So that's one possible solution in amongst the infinitely many solutions to this particular problem. Okay. So the last question we did in class was solving a 3 unknown simultaneous equation. And diagrammatically, that's kind of what it looks like. So if you want a little bit more, or want to know a little bit more about what you're actually doing when you solve three unknown simultaneous equations, you can have a look through these pictures here and the explanation. But I'm going to go ahead and just punch out the algebra. All right, so the way we did this in class is we labelled these equations 1, 2, and 3. Right, and we can quickly see that we can eliminate an x with equation 1 and 2. So I'm just going to do 1, take away 2. So I get negative 6y, so those eliminate. Negative 2y, take away 4y is negative 6y, plus z equals negative 1. Right, now to this one here, and what I'm going to do is I want to eliminate the x from 2 and 3. Okay. Now the issue is that x won't eliminate unless I multiply all of equation 2 by 2. So I'm going to form equation 4 by writing 2x plus 8y plus 4z equals 8. All right, so that's just this equation here rewritten. Okay, so now what I'm going to do is eliminate the x. So I'm going to do 4 take away 3. All right, so that's going to be 10y plus 3z. Where are we? 8y take away 4. I've just lost it there. 8y take away negative 2y is 10y. Yep, z, where are we? 4z take away 2z. Oh my goodness, I've lost it here. So just to pair these up, I just need to do this graphically. There we go, I can see it now. Okay, so I've got 8y, subtract negative 2y is 10y, 4z take away z is 3z, and 8 take away 4 is 4. Okay, so now what I want to do is I'm going to call this equation 5 and equation 6. All right, with equation 5, what I want to do is eliminate the z, I think is the logical one. So I'm going to multiply equation 5 by 3. Negative 18y plus 3z equals negative 3. So that's really forming equation 7. All right, so now I'll do 7 take away 6. Negative 18y, take away another 10y is negative 28y. 3z take 3z, eliminated. And this is negative 3 take away 4 is negative 7. Y equals 7 on 28 equals a quarter. All right, that's a good sign because that's what I got in class. Okay, so now what we'll do is sub y equals a quarter into, probably into, which one? There's equation 5, there's equation 6, it doesn't really matter, so 6 on 4, so I'm going to put it into equation 5. Negative 6 on 4 plus z equals negative 1. Negative 3 on 2 plus z equals negative 2 on 2. Z equals a half. Okay, so we've got x, we've got y, we've got z, we just need to get x. So I'll probably chuck it into this one here. So, just so I don't have to scroll. Okay, so what we've got is x take away 2 times a quarter plus 3 times a half equals 3. X take away a half plus 3 on 2 equals 3. Okay, so that's 2 on 2, which is 1. X take away 1 equals 3. X equals 4. All right, and we did do that one in class as well on the CAS, so algebra, solve system, and we had 3 equations, and if you tab that, you'll get 3 unknowns. So try it out yourself, just whack those in to the solve, and you should hopefully find that I got that right. Well, I hope you find that. So that was, yeah, that was that. All right, so get yourself up to date with those notes, and the homework was these questions here. So the Cambridge questions. So they weren't listed in the booklet. So you just need to make sure that you grab those questions or do those questions. All right, good luck.